Okay, so today we're going to look at solving quadratic equations by completing the square. Before we get into that, let's talk about the previous methods that we've used to solve a quadratic equation. The first one is just by factoring. So in this case, if you've got ax squared plus bx plus c equals 0, remember if your a term is equal to 1, all you need to do is find the factors of c that add up to b. So if I'm trying to find the factors of negative 10 that add up to negative 3, I think negative 5 and positive 2 looks like they might work. So negative 5 times positive 2 is negative 10. Negative 5 plus 2 is negative 3. So that's going to factor as x minus 5 times x plus 2, and that's going to equal 0. So remember, using the zero product property, we're going to figure out what value of x makes this factor equal to 0 and what value of x makes this factor equal to 0. So either x minus 5 equals 0, which would make x equal to 5, or x plus 2 equals 0, which would make x equal to negative 2. So those are your values for x. X either equals 5 or x equals negative 2. Now remember, the second method that we learned was just by taking square roots. If you're able to take a square root of both sides, then you can solve the quadratic. So here I've got x plus 4 squared equals 25. Okay, so if I take the square root of this side, I end up with x plus 4. And then if I take the square root of this side, remember I need to make that positive or negative 5, plus or minus 5. Okay, guys? So to finish solving for x, I can say x plus 4 equals positive 5, or x plus 4 equals negative 5. All right, so if I subtract 4 from both sides over here, I got x equals 1, or on this side, if I subtract 4 from both sides, I get x equals negative 9. Okay, so what we're going to talk about today again is solving quadratics by completing the square. Basically, it's another way to solve by taking square roots, but what we're going to do is add another step to it. Okay, so the second example, x plus 4 equals 25, that could be rewritten as x squared plus 8x plus 16 equals 25. Because remember, if I wanted to multiply this out, I've got x plus 4 times x plus 4. That's what x plus 4 squared means. So if I distribute, I get x squared, and then I get plus 4x, then I get plus 4x again, and then I get plus 16. And if I combine my like terms, I'm going to get x squared plus 8x plus 16, and that still equals 25. Okay? Remember, this right here, x squared plus 8x plus 16, that's a perfect square trinomial. Okay? Remember, the perfect square trinomial follows a pattern a squared plus 2ab plus b squared. Okay? And that's going to factor as a plus b or a plus b squared or a minus b squared, depending on the sign in front of 2ab. All right, so here you got a plus here, so it's going to factor as a plus b squared. So yes, x squared plus 8x plus 16 fits that pattern. Your a term, if a squared is x squared, then your a term is x. If b squared is 16, then your b squared is 4. It'd be the square root of that. Twice 4x is going to be 8x. So 2ab is 8x. So it does fit that pattern, a squared plus 2ab plus b squared. And it's going to factor as a plus b squared. So remember, your a term is x. So it factors as x plus your b term, which is 4, squared. Okay? So what is all this completing the square business about? Okay? Well, if a quadratic doesn't follow the pattern, like this example down here, x squared plus 6x minus 7 equals 0. X squared is a perfect square of x, but negative 7 is not a perfect square of anything, so it doesn't fit the pattern a squared plus 2ab plus b squared. It doesn't fit any of that. So how could we turn that into a perfect square trinomial so we can solve it taking square roots? Well, the first thing we're going to do is move the negative 7 to the other side of the equation. That's going to give us x squared plus 6x equals 7. Now what we need to do is we need to turn the left side of the equation into a perfect square trinomial using a process called completing the square. If you watch the next video, I'm going to walk you through how to complete the square.